Yes.
Right on. Next topic. Bohr's model, BOHR, Bohr's model of hydrogen atom. Bohr's model of hydrogen atom. See, if you remember in line spectrum or in black body radiation, I told you energy will be absorbed or will be released by an electron in the form of packets of energy. It means loss or gain of energy will not take place in a continuous manner. And for this packet of energy, I use the term quantum,
On. Yes,
right?
sir.
So this is the reason we can say that energy of an electron is quantized. If we say that energy of electron is quantized, it means it will lose or it will gain energy in the form of packets. It will not do so in a continuous manner, that it will absorb or lose a small quantity of energy. That will not happen. So this model is based on quantization of energy. Now write down. And moreover, why was this model of atom proposed? See, any new theory is proposed just to overcome drawbacks of previous theories. So previous theories were Thomson's model and Rutherford's model. Uh, to overcome drawbacks of those theories, this third theory, that Bohr's model, has come into picture. Right on. Bohr's model, Bohr's model was put forward to overcome drawbacks of Rutherford's model, Rutherford's model, and to explain line spectrum of hydrogen, line spectrum of hydrogen. This model is based on quantization of energy, based on quantization of energy. Its main points are, now I'll give you various points of this theory, and in between few points will be numerical based points. Right on. Number one.
So are these the postulates?
Sorry?
Are these the postulates?
Yeah, postulates.
Oh,
Postulates. Number one. An atom consists of nucleus at its center, nucleus at its center, which is surrounded by circular paths. Circular paths. Underline the word circular, because this circular word is a drawback of this theory, which I'll tell you at the end. Circular paths called orbits or shells or energy levels. Energy levels. These orbits are concentrically arranged. Okay, one outside the other. They all have the same center, concentrically arranged around the nucleus. So all these orbits have the same center. Number two, second point. Energy of electron in an orbit remains constant so long as it is present in a particular orbit. That is why an orbit is also called a stationary state. Also called a stationary state. It means there is a new term for orbit. Earlier we said orbit, energy level, shell. Now for the same we are will be using the new term, that is stationary state. Continue, same point. A stationary state does not mean that the electron is stationary, right? Because the electron is moving. Does not mean that the electron is stationary. Rather, it means that energy of electron remains constant. Energy of electron remains constant so long as it is present in a particular orbit. Next, third point. Earlier, I told you in photoelectric effect and other topics that an electron can absorb energy and go to higher shell, can lose energy and come closer to the nucleus. And this loss or gain of energy, as I said, topic is based on quantization, is will take place in the form of packets. And what is the frequency of the radiation emitted or frequency of the radiation absorbed for this transition of electron? That frequency can be calculated by simply using the formula E is equal to h nu. Energy or energy difference is same thing. Difference of energy will also be energy. And you know, energy E is equal to h nu. Therefore, I can say delta E, change in energy, will also be equal to h nu. So this will be the formula we are going to come across. Right on number 3, an electron can lose energy and come closer to the nucleus, or it can absorb energy and move away from the nucleus. This loss or gain of energy takes place in the form of fixed packets of energy. Frequency of radiation absorbed or emitted during transition, movement from one shell to another, during transition can be calculated by using the following formula. Delta stands for change. Delta E means change in energy. And remember, change is always final minus initial. So this is E final minus E initial. If I say electron goes from second shell to fifth shell, it means final energy will be E5, initial energy will be, it goes from second to fifth. The initial energy will be E2. E2 means energy of electron in shell number 2. How do we calculate the value of E2 and E5? That will come later in this very chapter, in this very topic. And this energy change is nothing but energy, and that will be equal to h nu. This relation is called Bohr's frequency rule. This is called Bohr's frequency rule. Next point. Lowest energy state. Lowest energy state means the lowest orbit in which the electron is present, right? Okay, lowest energy state of electron in an atom is called the ground state. Called the ground state. See, this Bohr's model is applicable only to those particles which have one electron. And if there's only one electron, naturally it will be present in shell number 1. So ground state for this theory is nothing but shell number 1. Right? Next. Bohr's model is applicable to hydrogen-like particles only which contain one electron. For example, hydrogen He plus. Helium atom has 2 electrons, plus means -1. So 2 minus 1, 1 electron. Li plus 2. Lithium atomic number is 3. 3 electrons minus 2. It also has 1 electron. So Bohr's model is applicable to this type of particles only. Next point. Angular momentum of electron present in an orbit. Underline orbit, because I'll be giving one formula here. In the next point also, I'll give you one formula again for Bohr's angular momentum. This is angular momentum for the electron present in orbit. Next will be angular momentum for electron present in an orbital. Orbit and orbital, they are different things which will come across towards the end of this chapter. So I'll repeat this point. Angular momentum of electron in an orbit is a whole number multiple of h by 2 pi. H by 2 pi. That is MVR is equal to n times h by 2 pi. N is a whole number, that is 1, 2, 3, 4, and so on. M is mass of electron, V is velocity of electron, R is radius of the orbit in which electron is moving. This ME means mass of electron, VE means velocity of electron, radius of orbit. Next point. Angular momentum of an electron in an orbital is calculated by using the formula Again, MVR is equal to L into L plus 1 square root into H by 2 pi. Now, what is this L? Again, you'll learn about this L towards the end of this chapter when we talk about modern electronic configuration. For the timing, I'll tell you, we can label it. This L is AZI MUTHAL azimuthal quantum number. Azimuthal quantum number. This is also called angular momentum quantum number. Modern electronic configuration is based on this only, and that we'll learn towards the end of this chapter. Next point. Now, if you want to calculate the radius of orbit in which electron is moving, because we'll have to use radius of electron orbit also. We'll have to calculate velocity of electron when it is moving in a particular orbit. For both, we have separate points. Next point, write down. Radius of orbit in which electron is present can be calculated by using the formula Rn. R means radius of shell number n. If I say radius of fourth shell, so I'll say R4 is equal to 52.9. You'll have to remember this, 52.9 into square of shell number divided by Z. This answer will be in picometers. Right? This will be in picometers. Now, you know, circumference is 2 pi r. It means what will be the value of circumference? 2 pi into this. Right? Right. And thus circumference of orbit is equal to 2 pi into 52.9 n square divided by Z. Right? So many picometers. Now, if we talk about the radius of shell number 1, I told you, is the ground state for those particles which contain one electron. So radius of the first shell is called Bohr's radius, right? Only the first shell I'm talking about. Radius of the first shell is called Bohr's radius, because in numerical sometimes they say Bohr's radius is this much. Then it is understood we are talking about radius of shell number 1. Moreover, if you look at the formula, radius is inversely proportional to atomic number. Atomic number is number of protons. It means as atomic number increases, it means positive charge in the nucleus will increase. When positive charge increases, attraction between nucleus and electrons will increase, and due to this, radius will decrease, right? Due to attraction between nucleus and electron, oppositely charged particles. Continues. Same point, next paragraph. Radius of first orbit of an atom is called Bohr's radius. It means with increase in atomic number, with increase in atomic number, that is nuclear charge, radius decreases due to stronger attractions between nucleus and electron. I'm sharing one numerical based on this simple relation. Yes, check your WhatsApp message. Very, very simple numerical. You'll find this numerical as in text numerical 6 in the description box of video. Calculate the radius of second shell of He plus ion. We have to calculate second. We'll label it R2. This will be 52.9 into n square. Shell number 2, it means square of 2 divided by Z. Atomic number of helium is 2. So this will, so many picometers. So this will be 2 times this. Answer will be 105.8 picometers.
Yes, sir.
Right? Next point. That was about radius, and we are now, you want velocity of the electron. Yes, next point. Velocity of electron in an orbit. Velocity of electron in an orbit can be calculated by using the formula (2.18 into 10 to the power 6) multiplied by Z, that is atomic number, divided by n meters per second. So if I want to calculate the velocity of electron present in shell number 5, so this will be 5, and if the particle is He plus, Z will be 2. I can calculate. So again, a very, very simple numerical I'm sharing on WhatsApp. You'll find this as in text numerical 7 in the description box of the video. Yes. Calculate velocity of electron in 4th orbit of He plus ion. 4th orbit. 2.18 into 10 to the power 6. Z for helium 2. 4th orbit, n is 4. Multiply, divide, you'll get the answer. It will be half of this, 1.09 into 10 to the power 6 meter per second. This is the velocity of electron in 4th shell. Next point. See, if you want to calculate total energy, we sometimes call it energy of electron, or sometimes we call it total energy of electron. There are 3 relations depending on units in which we want to calculate. Write down. Energy oblique total energy. For total energy, generally we write TE. Energy oblique total energy of electron in an orbit can be calculated by using following formulas. I'm giving you 3 formulas. En, energy of electron in shell number n. This is nothing but TE, total energy in shell number N, is equal to minus 2.18 into 10 to the power minus 18, 2.18 into 10 to the power minus 18 into Z square divided by N square. For this formula, units will be joules per atom. Joules per atom. Second relation. Second is 13.595. We can use 13.6, right? 13.595. Remaining will remain the same into Z square divided by N square. This is electron volt per atom. Now, if you want to calculate the value in kilojoules per mole, first two were for per atom. If you want to calculate for 1 mole, then it is minus 1312 into Z square divided by N square kilojoules per mole.
So is the derivation the part of syllabus or no?
Sorry?
The derivation of these formulas?
No. Derivations are never asked. Derivations are too complicated. No. Now, I'll tell you relation between total energy, kinetic energy, and potential energy. Although very rarely used, but if required, write down. Total energy is equal to minus kinetic energy. And that is further equal to potential energy divided by 2. Right? Now, if we look at this relation, there are 2 points. First, very simple point, which I'll explain. Then second will take little time. See, I have rubbed those 3 relations. In all those 3 equations, in the numerator, it was Z square, atomic number, square of atomic number. It means as atomic number increases, energy of the electron will become more and more negative. More negative means less energy. That is one point. First, we finish this one. According to above equations, with increase in atomic number, energy becomes more and more negative. More and more negative. Now comes second and a very, very important point. See, if we talk of ourselves, sometimes I say I'm very energetic today. Sometimes I say I'm too tired. I'm at low energy today. Energy can be high. Energy can be low. Energy, I have no energy, means zero, although it's not possible. But how can the energy be negative? In these 3 formulas, in all the 3, En is equal to minus something, isn't it? Negative. How can the energy be negative? This is something which is generally asked in CBSE exam. Let me explain that. See, so long as electron is present in an atom, there's attraction between negative electron and positive nucleus. Imagine that this electron has been completely removed from the atom, or I can say it has been taken away at infinity distance from the nucleus. At this stage, there's no attraction between nucleus and electron. When there's no attraction between nucleus and electron at infinity distance, electron is arbitrarily assigned energy equal to 0. I'm not saying its energy is 0. It is assigned energy equal to 0. Now imagine if that electron from infinity is brought closer and closer and closer to the nucleus. And attraction between nucleus and electron will keep on increasing. And remember, attraction will always release energy. So as electron comes closer and closer to the nucleus, attraction becomes more and more stronger, means more and more energy is given out. Earlier energy was 0. Now from 0, if some energy is given out, naturally energy left will be negative. So, but remember, when we calculate, on calculation, this will come out to be positive, because we never calculate energy. We generally use energy difference. When electron goes from one shell to another, we use energy difference, and difference will be a positive value in that case. Right. Second point, next paragraph. According to above formulas, energy of electron in an orbit is negative, which can be explained as follows. Now write down the explanation. When electron is taken away at infinity distance from the nucleus, that is, within brackets, that is n is equal to infinity. N means shell number is equal to infinity. Now think, if you substitute n equal to infinity in those formulas, energy will come out to be 0. Right? So, okay, I'll repeat. Is taken at infinity distance from the nucleus, that is n is equal to infinity, comma, atom is ionized. Atom is ionized. At this stage, electron is assigned 0 energy. Remember, assigned, I'm using the word assigned. Assigned 0 energy. At this stage, there is no attraction between nucleus and electron. Full stop. As electron comes closer and closer to the nucleus, attraction between them becomes stronger, thereby releasing some energy, not some energy, rather you should write releasing more and more energy, due to which value of energy of electron becomes negative. Now check your WhatsApp message. This is numerical number 8. I'm sharing numerical number 8. We'll solve this one. Calculate energy required to promote an electron from first shell to fourth shell in 1 mole of helium ions. First of all, we have to decide which formula do we use. See, it is given 1 mole of helium ions. We'll have to use the formula number 3, in which the value was calculated in kilojoules per mole. Electron is to be shifted from shell number 1 to shell number 4. So I'll calculate E1, I'll calculate E4 is equal to minus 1312 multiplied by Z, Z square. Z is for helium is 2. It means 2 square divided by N square. Shell number 1, square of 1. Shell number 4, square of 4. So when you calculate, first value will come out to minus 5248 kilojoules per mole. Value of energy in fourth shell will be minus 328 kilojoules per mole. Now we have to calculate energy change. This will be final, that is minus 328 of minus this value, minus 5248. This will be the amount of energy required to promote electron. This will be 424920 kilojoules per mole. So this will be the energy required for promotion of electron from shell number 1 to shell number 4 in 1 mole of helium ions. Remember that, 1 mole of helium ions. Now we are coming across 3 very simple terms. Before that, let me explain. At the center is nucleus surrounded by orbits, and electron is present in the ground state. Generally, if there's one electron, ground state will be shell number 1. If I want to promote electron from ground state, that is shell number 1, to any other higher shell, let us say shell number 2, shell number 3, shell number 4, for this purpose, energy required will be called excitation energy. Excitation energy. Second, in case electron is already present in a higher shell, it means any shell other than ground state. If it is present in shell number 2, 3, 4, 5, any other higher shell, from there, if I want to completely remove electron, remove means I want to take it at infinity distance from the nucleus. That is called ionization. For that, how much energy is required? That is called separation energy. First was excitation energy. Second is separation energy, which is required to remove electron from higher shell completely to infinity. And third is ionization energy. Ionization energy will be energy required to remove electron from ground state to infinity. Ground state to completely knock out from the atom. That will be called ionization energy. So write down these 3 terms. First, write down excitation energy. Excitation energy. Write down this is the energy required to promote electron to any shell from ground state. Any shell from, shell means orbit, from ground state. Second definition, separation energy. This is the minimum energy required to remove electron from excited state of an atom, right? From excited state. Next definition, ionization energy. This is the minimum energy required. This is the minimum energy required to remove an electron from the ground state of an atom. Ground state of an atom, right? So again, excitation was to excite the electron from ground state to any other higher shell. Separation energy was from excited state, we knock out the electron, how much energy is required. Third, ionization, from ground state to completely knock out the electron, how much energy do we need to supply? That is called ionization energy. Next paragraph. Again, one more relation is coming. So many formulas in this theory. And kinetic energy of a charged particle. It may not be necessarily electron, any charged particle. Kinetic energy of a charged particle under an applied electrical potential, under an applied electrical potential can be calculated by using the formula, write down the formula. Number of units of charge on the particle. If I say 1 unit of charge means 1.602 into 10 to the power minus 19 coulomb. If I say 5 units of charge, it means 5 into 1.6 into 10 to the power minus 19 coulombs of charge. So units of charge on the particle multiplied by potential applied in volts. Potential applied in volts. And although you should, I think, know, but still, you know, 1 electron volt is 1.6 into 10 to the power minus 19 coulomb. You can round off and use this value 1.6. There's no need to write 1.602. One numerical based on this relation. This will be in text numerical number 9. 7. Check this one. Numerical is calculate kinetic energy of Li plus 2 ion. What is the charge on ion? It's mentioned Li plus 2 means 2 units of charge. So kinetic energy will be 2 units of charge multiplied by the potential applied. In this numerical, under an applied potential of 1.2 volts. 1.2. If you multiply, this answer will be in electron volts. Now, if you want to convert into joules, just now I told you 1 electron volt is 1.6 into 10 to the power minus 19. So this into 1.6 into 10 to the power minus 19 joules. This will be the answer, 3.84 into 10 to the power minus 19. Now coming to the last part of this theory. limitations of Bohr's model. Limitations of Bohr's model. Number one. First, you write a common sentence, then we'll write point wise. That it could not explain. Now write on number one. So it could not explain is common. It could not explain, number one, 3D model of an atom. 3D model of an atom. See, atom is not a circle, atom is a sphere. It means it is a spherical object, three-dimensional object. But according to the very first point of Bohr's model, he said electron is revolving around the nucleus in circular paths, and circle is two-dimensional. So this model does not explain that the atom is three-dimensional. Number two, line spectra of multi-electron particles. Multi-electron particles. In one of the points I told you that Bohr's model is applicable only to those particles which have one electron. And in next topic, in the next class, I'll tell you that this Bohr's model is used to explain line spectrum of hydrogen, or I can say is used to explain line spectrum of all those particles which contain one electron. So this drawback is that it cannot explain line spectrum of those particles which have more than one electron. Third drawback, splitting of lines in an external electric field within brackets, write down Stark's effect. First you write, then I'll explain. Stark's effect and splitting in an external magnetic field within brackets, Zeeman's effect. See, after this Bohr's model was proposed, long after that, it was found that when highly sophisticated instruments were used, then spectral lines, they were found to further split into, each spectral line was found to split into two or more lines under the influence of external electric field as well as under the influence of external magnetic field. This splitting of spectral lines under the influence of electric field is called Stark's effect, and splitting in the presence of magnetic field, that is called Zeeman's effect. Next point. See, it was found that if those spectral lines, they were analyzed by using high definition instruments, then without applying any external or electric or magnetic field, even those lines had two or three lines combined together. They were very close but could not be seen otherwise. These are called doublets or triplets. So write down next point. Formation of some closely placed lines called doublets or triplets in the spectrum of hydrogen, which were observed later. Next point. In one of the points, I told you that angular momentum is a whole number multiple of h by 2 pi. Why it is so? There's no derivation, no explanation about that. So that is another drawback. So next is Y, the angular momentum of electron in an orbit is equal to n into h by 2 pi. So that was not explained. Last three very small simple points. Next, ability of atoms to form molecules. So why do atoms combine and form molecules? That was not explained by Bohr's model. And last two limitations, last two drawbacks will be next two topics of this chapter. Next, write down dual nature of matter and electron dual nature of electron and matter. So like we say that there's dual nature of radiation, which we finished earlier. Similarly, any particle in motion is also associated with dual nature, that is particle as well as wave nature. So that was not explained. We'll take up that topic in the next class. And last limitation, Heisenberg, Heisenberg, Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. So these last two limitations will be two topics in the next class. These are very small topics. We'll finish in one class only. Right. So that's all for today's class.